In this video, we're going to look at another example of an improper integral. We'll determine if it converges or if it diverges, and if it converges, what it converges to. So let's take a look at this example. Determine if this improper integral, which is evaluated from 0 to 4, of 1 over square root of 4 minus x, converges or diverges. Now, what makes this an improper integral? The function f of x equals to 1 divided by square root of 4 minus x is undefined at 4, which is the upper limit of integration. As x approaches 4 from the left side, this function becomes unbounded, as we'll see later in its graph, and that's what makes this an improper integral. So the way we would handle it, we look at the interval from 0 to 4. We let t represent a number between 0 and 4. If we integrate from 0 to t for any t, as long as it's less than 4, the integral will be perfectly fine. And so the improper integral, 0 to 4, of 1 over square root of 4 minus x, is defined as the limit, with t approaching 4 from the left side, of the integral from 0 to t of 1 divided by square root of 4 minus x dx. So one method is to find antiderivative of 1 over square root of 4 minus x. And we can do that using pretty simple u substitution. Just let u equal to 4 minus x. du is negative dx, or negative du equals to dx. We'll replace dx. So in variable u, the integral becomes the integral of 1 over square root of u times minus du, which is a basic integral. So we can pull the minus out, write u to the minus 1/2 du, and use anti-differentiation formula, add 1 and divide by the new exponent. This will be minus u to the 1/2 over 1/2, or negative 2 times square root of u. And then back to x, it's negative 2 square root of 4 minus x. That's the antiderivative. So now we can evaluate the improper integral. One more time, the integral from 0 to 4 of 1 over square root of 4 minus x dx is equal to the limit as t approaches 4 from the left side of the integral from 0 to t of 1 divided by square root of 4 minus x dx. We just found the antiderivative of this. So this is the limit as t approaches 4 from the left of negative 2 minus 2 square root of 4 minus x, evaluated from 0 to t, which is the limit as t approaches 4 from the left, negative 2 square root of 4 minus t, minus a minus or plus 2 square root of 4 minus 0, which is just square root of 4. And of course, as t approaches 0, t approaches 4 from the left, 4 minus t approaches 0 from the right, and 2 times square root of 4 is equal to 4. So hence, the improper integral 0 to 4 of 1 over square root 4 minus x dx converges to 4. Here's another way to do this. We can make the substitution initially rather than waiting. Then after the limit, we can make the substitution before taking limit. So we write the integral again. Let u equal to 4 minus x. du will be negative dx, or minus du is dx when x is 0. U is 4. When x is 4, u is 0. So let's carefully transform this to integral in variable u. The integral from 0 to 4 of 1 over square root of 4 minus x dx is the same as the integral from 4 to 0, 1 over square root of u times negative du. We can exchange negative with flipping the order of integration. So this will be the integral of from 0 to 4, 1 over square root of u du. Here we have the u interval from 0 to 4. We can see 1 over square root of u is undefined at 0 rather than at 4. So we need to, that's what makes this, this integral improper, the fact that 1 over square root of u is undefined at 0. So we let t represent any number between 0 and 4. The integral from t to 4 will be defined, and we let t approach 0 from the right. That will equal to, that will be integral from 0 to 4, 1 over square root of 4 minus x dx equals to integral from 0 to 4 of 1 over square root of u, which is u to the negative 1/2 du. That's equal to the limit as t approaches 0 from the right of the integral from t to 4, u to the negative 1/2 du. And now we can integrate this. So this is limit t approaches 0 from the right of 2 u to the 1/2 evaluated from t to 4. And that's equal to the limit as t approaches 0 from the right of 2 square root of u evaluated from t to 4. And that's limit as t approaches 0 from the right. Let's plug in 4 for u. We get 2 square root of 4 minus 2 square root of t. You can see as t approaches 0 from the right, 2 square root of t approaches 0. And that leaves us with 2 times square root of 4, which is 4. And hence the improper integral from 0 to 4 of 1 over square root of 4 minus x converges again to 4 using method number 2. And now we want to sketch the graph of this function and see what this integral represents. So here is the x and y axes, the plane. This function 1 over square root of 4 minus x has a vertical asymptote at x equals to 4. When x is 0, it's 1 over square root of 4, which is 1/2. And there's the vertical asymptote at 4. And this is what the graph looks like. It's unbounded as we get closer and closer to 4 from the left side. So that's the graph of f of x equals to 1 over square root 4 minus x. And then the integral represents the shaded area right in here, going all the way to the top, running along the line x equals to 4. So this area right in here, again going all the way to the top along the vertical line x equals to 4, that area is equal to 4. That's what the improper integral just computed. It computed that area.